Did NASA find life on Mars? Mars has always been a world of mystery. To the naked eye, it appears as a faint red dot wandering across the night sky, but through telescopes it became a world of speculation. In the 19th century, astronomers like Giovanni Schiaparelli reported canali on Mars, channels that some misinterpreted as artificial canals. The idea of Martian civilizations took hold, inspiring authors like H.G. Wells to imagine alien invasions and dying worlds. As the decades passed, science replaced myth with evidence. Probes revealed not sprawling cities but desolate deserts, and yet, the deeper we looked, the more Mars whispered a different kind of story. Ancient rivers, vast lakes, a planet that may once have been alive. NASA's quest to answer the question of Martian life has stretched across generations, from the Viking landers of the 1970s to the Perseverance rover today. Each mission has uncovered tantalizing clues, none conclusive, but together they paint a portrait of a world that may not be as dead as it seems. Tonight we follow the search for life on Mars, what NASA has found, what it hasn't, and what the future may yet reveal. At first glance, Mars is unforgiving. Its thin carbon dioxide atmosphere offers little protection from cosmic rays. Daytime temperatures may briefly rise above freezing, but nights plunge to -100 degrees Celsius. Dust storms engulf the planet for weeks, cloaking it in ochre haze. But this harsh present conceals a gentler past. Billions of years ago, Mars was warmer and wetter. Orbiters have mapped vast valley networks that snake across the surface, clear evidence that liquid water once carved the land. Rover cameras have captured images of rounded pebbles, shaped not by wind but by rivers tumbling them for eons. Sedimentary rocks reveal ancient lake beds, layered with deposits that could have preserved microbial fossils. NASA's Curiosity rover discovered that Gale Crater once hosted a long-lived lake. Perseverance is exploring Jezero Crater, where a river delta still scars the land. These sites were not temporary puddles. They were stable bodies of water existing for millions of years. On Earth, life arose in similar environments. If Mars had lakes, rivers, and even oceans in its northern lowlands, then it had the essential ingredient for life: liquid water. Combined with a thicker atmosphere and active volcanism providing energy, early Mars may have been not just habitable, but inhabited. In 1976, NASA attempted the first direct life detection experiment on another planet. The Viking 1 and Viking 2 landers touched down on the Martian surface, each equipped with instruments to test for microbial activity. The results shocked scientists. One experiment, they labeled Release Test, mixed Martian soil with nutrients tagged with radioactive carbon. To the surprise of mission scientists, the soil released gases that looked like the byproducts of metabolism. On Earth, this would have been considered evidence of microbial life. But another experiment, the gas chromatograph mass spectrometer, found no organic molecules in the soil. That absence contradicted what life should produce. The verdict was confusion. Some declared that Viking had found life, only for others to argue the reactions were caused by reactive chemistry in the soil, perhaps perchlorates breaking down nutrients. To this day, the Viking experiments remain debated. Some astrobiologists believe we may have glimpsed life in 1976 and dismissed it as error. Others say the conditions were too extreme. The truth is buried in history and in the soil of Mars itself. Decades later, a new Martian puzzle emerged: methane. In 2003, telescopes on Earth detected plumes of methane in Mars's atmosphere. On our planet, most methane comes from biology, microbes called methanogens. But methane can also come from geology, such as volcanic activity or water rock reactions. Curiosity confirmed occasional spikes of methane near Gale Crater. These spikes varied with the seasons, rising in summer, fading in winter. The pattern hinted at something active beneath the surface, yet the European Space Agency's trace gas orbiter, designed specifically to detect methane, found little to none. How could one instrument see methane while another did not? The mystery deepens. If methane is truly present, it could mean subsurface microbial life. If it is absent, it may all be illusion. The question remains unanswered, but tantalizing. While methane whispers from the air, Mars's rocks tell louder stories. In 2018, Curiosity detected organic molecules locked in 3 billion-year-old mudstones. These molecules are not proof of life, but they are the raw ingredients. On Earth, organics combine with water and energy to spark biology. Perseverance is pushing further. It landed in Jezero Crater, a dried-up lakebed fed by a river delta. The delta's fan-shaped deposits resemble Earth's most fertile microbial environments. Already, Perseverance has drilled samples containing carbon-rich materials and sulfate minerals, signatures of potential biological processes. What makes this historic is that Perseverance is caching these samples in sealed titanium tubes. Within the next decade, NASA and ESA plan to return them to Earth for analysis. In the world's best laboratories, scientists may finally answer the question, did Mars once host life? If the answer is yes, the evidence may already be waiting, preserved in those small cylinders lying on the Martian surface. In 1996, NASA scientists announced a discovery that made global headlines. Inside a Martian meteorite called ALH 84001, found in Antarctica, they identified structures resembling fossilized bacteria. They also detected unusual chemical compounds, often associated with biology. The news reached the White House. President Bill Clinton addressed the world saying, if this discovery is confirmed, it would be one of the most stunning insights into our universe that science has ever uncovered, but confirmation never came. Critics argued that the structures were too small and the chemistry could be explained by non-biological processes. Over time, the consensus shifted away from biology, yet the meteorite left its mark. It inspired a generation of scientists, sparked new missions, and reminded us how extraordinary the stakes are. If life did exist on Mars, even billions of years ago, then Earth is not unique. Life may be common in the universe. One challenge of the Martian search is defining what life even is. On Earth, life leaves patterns, isotopic ratios, complex molecules, organized structures. But Mars complicates things. Perchlorates in its soil can destroy organics during heating. Radiation breaks apart molecules on the surface. Ancient signs may be altered beyond recognition. This means that proving Martian life requires overwhelming evidence. Not just a molecule or a spike of gas, but complex patterns no chemistry alone can explain. That's why NASA is cautious. Every claim of life must withstand extraordinary scrutiny. The cost of a false positive, claiming life where none exists, is too high. Still, the tantalizing evidence mounts. Mars has given us organics, methane, possible fossils, and habitable environments. The line between chemistry and biology is razor thin, and we may be standing right on it. The search for Martian life is far from over. The Mars sample return mission, launching later this decade, will bring Perseverance's caches back to Earth. For the first time, scientists will study Martian rocks with instruments far beyond what a rover can carry. Meanwhile, orbiters will continue scanning for trace gases. New missions may drill deeper, reaching below the radiation-blasted surface to subsurface aquifers that could still harbor microbes. And then there are humans. Within the next few decades, astronauts may set foot on Mars. With their hands and eyes, they could search directly, speeding discoveries beyond what any robot could achieve. Mars may be barren today, but beneath its dust it may yet reveal life, past or present, or... For more than a century, Mars has been the canvas for our imagination. From canals to microbes, from meteorites to methane, the red planet has always carried the weight of one haunting question. Are we alone? NASA's discoveries show us a planet that was once warm, wet, and welcoming. A world that had all the ingredients for life. A world that may still hold it deep underground. Have we already glimpsed life and failed to recognize it? Or is the answer still hidden, waiting in the samples Perseverance left behind? One thing is certain. In our lifetime, we may finally solve the riddle. And if Mars ever hosted life, even microbes, then Earth is not unique, and the universe is likely teeming with possibilities. This is Skyward Space Quest. Don't forget to like this video, subscribe, and join us next time as we continue our journey into the cosmos.